Hi, and welcome back. I'm Terry Burns, and this is a continuation of my class on the Monas Hieroglyphica of Dr. John Dee, using the translation that Dr. Nancy Turner and I had come out a couple years ago from Ouroboros Press. First of all, congratulations if you have gone through the letter to Maximillian with me, seen the introduction and the context. We're ready to start on the theorems, and you are starting at the place where most people do. And maybe now you understand why most people get so confused. All of the context that we've talked about that was set up in the letter is something that you need to have in mind when you are going through these theorems, which is what we're going to do. And you're going to find the theorems easy because you have all of that preparation. I've been studying the Monas for going on 2 decades now, for those of you just joining us here with the theorems. So I've put a lot of time into this, so you don't have to. The Monas Hieroglyphica is a very understandable text. It just takes time and a good translation and the willingness to visualize geometric forms and shift between context. So if you're here now, you should know who John Dee is, what the Monas Hieroglyphica is, that it was written in 1564, the result of 7 years of gestation. That 7 is a very important number to John Dee. He wrote it and dedicated it to King Maximillian, whose coronation he had been at. And 6 months after this, Maximilian will become Holy Roman Emperor Maximilian II. Dee also says that Queen Elizabeth I of England is a holy witness to his secrets, meaning that he has explained the monad to Queen Elizabeth and she too understands it. Our previous videos have focused on the opening letters as a way to set the context. We're looking primarily at how it is a cosmogenic text. That is, these theorems we're going to look at will talk about how the cosmos were created, using background from Plato's Timaeus, where the great craftsman creates the universe from geometric forms, the Sefer Yetzirah, where the 22 letters of the Hebrew alphabet create creation, and the related Hermetic Kabbalah, not Rabbinic Kabbalah, but Hermetic, or what was at one time called Christian Kabbalah, starting the generation or so before Dee with Reuchlin, and the Bible, especially, of course, Genesis, that's where we get the word cosmogenesis, and the book of Revelation. So please watch the earlier videos first, or if you don't, at least watch the video on context, because context is going to be really important, and I will explain why. But if you have the context, this video will sort of take you through how to apply those contexts to read the theorems, and then we'll explicate the first 3. All right, what Dee is doing in these theorems is explicating this symbol of his, this monad symbol, his symbol of one, of everything. He has used it on other works. Here it is on his Propoitomata Aphoristica. It's picked up later in the Rosicrucian movement. It's, for example, in the Chemical Wedding of Christian Rosenkreutz, among other places. And other people use it in other times. Athanasius Kircher will use an adaptation in his Oedipus Egyptus. His Hermetic Cross looks a bit like the monad. We can find a version of the monad in a work of Heinrich Kuhnrath, who also takes Dee's idea, direct quote of Dee's idea of real versus spoken Kabbalah from the letter. Same thing with Antonio Foscarini. He, not with the monad symbol, but with quoting the real versus spoken Kabbalah. And he will directly not quote, but just appropriate some theorems. Another Italian writer, Capaccio, will have a symbol of Mercury that looks influenced by the monad. So many writers are borrowing from one another. Now, I'm going to assume if you know one Renaissance writer, it's probably William Shakespeare. So if you studied Shakespeare in school, think of all of his borrowing. We're told that the only play that doesn't have a source where that story is told before in a less skilled way is The Tempest, his very last play. So our ideas of plagiarism now just didn't apply back then. Everyone borrows from everyone else. So of course, Dee does the same thing. And he rarely names his sources if he is talking to someone who would know those sources, because it would be a kind of insult to say, Oh, you know, in the Bible, there is this guy, Jesus, who says, I mean, so Dee never says when he's referring to the Bible, he will direct you to particular verses. He doesn't refer to particular places in Euclid's geometry. He is referring to Plato all over the place. He's a Neoplatonic writer, but he doesn't refer to chapter and verse of the Timaeus or the Republic. He will mention other less known ancient Greek writers like Empedocles, for example, who will come up here. And he doesn't mention the Sefer Yetzirah. He assumes that if he's talking about Kabbalah, he's talking to someone who knows it. So the idea that the 22 letters are what is creating the tree is not well known to everyone then. Of course, not everyone, but to the super educated. And Dee is writing to the super well educated. Holy Roman Emperor Maximillian II is a very educated man, and Dee's audience is a rarefied, all puns intended, super educated audience. Dee has made at least 4 attempts in his life at a large body of theorems. In the letter, he talked about his aphorisms to the Parisian. They were mathematical, but not mathematical in our sense, but they were sacred mathematics. That's where he says he coined the term gamea, which is a magical talisman that he defines for his earth of marriage. And then, of course, the Propoinomata Aphoristica. So since these are theorems, he has 2 collections of aphorisms that remain and one we don't have. We might ask ourselves, what's the difference between a theorem and an aphorism? And I'm going to do that simply to talk about how somebody looks at punning and word association, because John Dee goes crazy with word association. If you don't love to play with language, it's hard to come to these theorems with a sense of play. But if you love to play with language, you love to make puns, you love associative word games, you'll love these theorems. All right, Dee's Propoinomata Aphoristica, that's 120 preliminary teachings. I apologize, in an earlier video, I said there were a couple hundred. It only feels like a couple hundred. We don't have this in a playful translation, and there's only one History of Science translation, and it is hard to get through. But these come out, here's the frontispiece with the monad symbol. It comes out before the Monas Hieroglyphica in 1558, then after in 1568. So an aphorism in English and a theorem are not the same thing. They are related, but an aphorism is just a sort of a wise, pithy statement. Well, a theorem in mathematics is something you can prove to be true. In logic, it's a statement where you can deduce things from the axioms that lead up to it. So an aphorism and a theorem are not the same thing. However, if your wise, pithy saying is something you can prove to be true, then they would be very related things. Okay, both terms come from Latin, and the Latin terms come from ancient Greek. And I want to just take apart the ancient Greek in both of these words to show you some things in them that might interest Dee and hopefully will interest you too. So aphorizo is an ancient Greek I define, I mark off, I determine. It can be a boundary. If you think of the boundary in Plato's Republic, the boundary between light and shade, for example, how you mark off things. But look at this word too. This is where we get our word for hour, horos. And gee, 24 theorems, 24 hours in a day, that is a kind of demarcation that it'll be real important to Dee. And Dee will love to go back and forth between measures of space and measures of time, as we will see. If you think of a clock face as a circle, the boundaries are increments of time, of course. So let's look at theorem. A theorem is to speculate. It's a proposition like that you need to prove. That's from Euclid, okay? Dee wrote the introduction to the first English translation of Euclid. He knows Euclid very well and what Euclid considers a theorem to be. One might guess that he's switching over and calling these theorems because this is a geometric text even more than the Propoinomata Aphoristica, which some people consider like a guide to navigation when you have lights from the stars, how to figure between them where you are, although it is also much more than a guide to navigation. Look at some other things here in the word theorem, though. It can mean a spectator. That's where we get not only our word theory, but our word theater. So you're a spectator, but also theos, our word that is like in theurgy or polytheism, monotheism, the worship of gods. So the person who is doing that worship is a type of spectator, or the words are related. This geometry that D is talking about in the hieroglyphic monad is sacred to D, and he's assuming it also will be to Maximillian. So, and also this word here, to see and look, is it related? Well, today, if we were taking a class in ancient Greek, we would probably be told, well, not really. They are related, but not in any meaningful way. D would not believe any of this any meaningful way. Any way that parts of a language are related, especially ancient Greek, or one of his three sacred languages, ancient Greek, Hebrew, Latin, he's going to find significant. He is looking at the world has created from language, and language has shapes. So geometric shapes, and he's using Plato's conception of forms, the idea that you visualize these shapes and there is a perfect form. So you're solving these theorems, and you're trying to match your visualization, your proof of a theorem, to this perfect solution that already exists. Okay, so he has all kinds of puns available with these two terms. He uses them, but also he's using the terms as very interchangeable. All right, now we're to the opening title of the theorems. He says he's going to explain these mathematically, magically, kabbalistically, and anagogically. Remember, anagogy is the fourth and highest level of scriptural exegesis. It comes out of the Middle Ages. I know that's not thrilling, but it's a word you need to know. And it has to do with analyzing a text in terms of the ascent back to the one. And that one would be the monad, right? Right. Okay, so let's get started. And you'll see if you have a copy of the theorems with you, and if you don't worry, they'll be on the screen. The first few look pretty easy. So we're going to take the first one, which is the shortest, and just look at translation and what can be the problem with translation. I started this whole project 2 decades ago because I was sure I could make sense of this, but something seemed to be missing. So let me give you an example of what I mean. Here is Theorem 1 in the original Latin. So let's go through it here. Per lineam rectum, curriculumque, prima, simplicissimaque fiat rerum, tum, non existentiam, tum in nature latentiam in eulocris in lucum productio representatioque. All right. Here's the first English translation, Hamilton Jones. People give Hamilton Jones a hard time, but his Latin is not that bad. Now, he only translates the theorem, and that's part of the difficulty you get into with Hamilton Jones. But his translation is free on the internet. So if you can't get mine, I go for Hamilton Jones rather than one of the other free translations on the internet, because they tend to be not as good. So it is by the straight line in the circle that the first and most simple example and representation of all things may be demonstrated, whether such things be either non-existent or merely hidden under nature's veils. Okay, let's look at the first scholarly translation. This is C.H. Jostyn, 1964. People who look at Jostyn's translation in Iambics in 1964, where he has the Latin and his translation right next to each other, all agree he is really good with Latin. You can learn a lot from Jostyn and how he solves particularly long Latin phrasings of D. So this is what Jostyn says. The first and most simple manifestation and representation of things, non-existent as well as latent in the folds of nature, happen by means of straight line and circle. Okay, so if this were a Latin class, which it's not, what we'd notice is that Hamilton Jones has stuck some words in here so that he can get this to be grammatically correct, but he's got almost the basic idea if you forget about context. And Jostyn has a a more stylish version. This one by Agnes Klein is in German. I put it up there for a particular reason, so I'll get back to it in a second. This comparison of theorems is something Dr. Nancy Turner and I had published back in 2007, and it's still online in the Journal of the Western Mystery Tradition. We compared translations of these three and two others, and for three different theorems. Also, our early translation of the first 17 theorems is still there too, if you want to go along through the first 17 with an old translation of ours. So there is a problem though with these two translations. Remember our contexts. A big context in a cosmogenic text is Genesis. So in the Latin Vulgate Bible, which is what Dee would use, you may recognize these Latin words in English. And God said, let there be light. And there was light. This is like really important. And what has happened here? God's light is missing. This is a bad thing, okay? God's light is missing. Something has left out here. This is what is left out. This is light. And I put Klein's German translation up here because I don't read German terribly well. I more guess at German than read it, but my co-translator, Dr. Turner, had a minor in German, so she was able to read through these. And one of the first is light. That's the word for light in German. Okay, so in these English translations, there's a problem in what happened to God's light. So if we look at one translation that didn't exist back in 2007 when Nancy and I were doing it, that's Egan's translation. Of course, our translation of the first 17 did exist, so he could kind of lean on that because, as Egan himself says, his Latin is, he never really studied it. So he tends to have a lot of problems in his translation. So when he says the first and most simple representation of not only existing things, this is wrong. Up here, it's non-existing things. How can something that doesn't exist be represented? Oh, go back and read Plato's Republic and you'll find out. But this is just wrong. However, what Egan is very good at is trying to figure out what the theorem means rather than just what this word will connect to in English. So he gets the light in here. It's very wordy, but he says, but all things hidden in the folds of nature and also in the exhibition of bringing forth of light is made by means of a straight line and circle. So he gets the context, or at least that part of it, even though he's making, getting some words very wrong in his translation. All right. This is how we translated it. Theorem 1, by virtue of the straight line and circle, the first and most simple manifestation of all things, non-existent or merely hidden in the veils of nature, is produced in light. So let's explain what Dee is talking about. One of the things I've mentioned previously in the letter and context video is that the compass and straight edge are required tools for doing ancient Greek geometry. Not only are you visualizing, but if it's two-dimensional geometry, you're using a straight edge or a ruler and a compass. And there are some very profound metaphysical things we could say about them, like, well, it's very hard to draw a perfect circle, but if you have a compass, you put the tip of it down, you find a point, and most people can draw a circle. That's sort of an amazing thing. It's like seeing an almost perfect version of that perfect form. Wow, I just did that, but I couldn't do it without this tool. They're the symbols for international Freemasonry, among other things, and they appear in non-Western cultures as well. So every theorem you should be able to visualize and execute it as a compass and straight edge problem. And when you get to theorem 23, he's going to take you through how to draw the whole monad within a circle with a compass and straight edge, but we've got a ways till we get to that one. So we've got the light in there. The straight line and circle are produced in light. I want to compare this quickly to a similar aphorism in his Propoitomata Aphoristica, but it probably won't seem similar. So let me show you what's going on here. D says in Aphorism 4, whatever exists by action emits spherically upon the universe various rays which, in their own manner, fill the whole universe. This is using Shoemaker's translation, which was done in the 70s. It's the only one that exists. So whatever exists by action. When in the Timaeus, the wise craftsman creates the universe, you have the first things being forms, and the forms are rotating, just as your mind rotates when you contemplate them. Remember the rhetorical trope of a dianoia that we talked about. So then that action emits spherically. Okay, here's a circle, and here it's a sphere. You have to be used to, indeed, flipping between different frames of reference and different dimensions. So you go from a line to a plane. You go from a circle, 2D, to a sphere, 3D, a square to a cube. And the higher dimension is always, always, always implicit in the low. So this straight line is it is the rushing out of light in a ray. These are various rays of light. If you remember from geometry, the difference between a line and a ray, okay, a line goes infinitely in either direction. When you end it, you have a line segment. But if it starts at a point and continues off infinitely in just one direction, then it's a ray. So here, instead of a line and a circle, we have a sphere and a ray filling the whole universe, rushing out and creating the universe. So the sphere will also connect to the cosmogony in Timaeus. There's a point we're told, and as he was to contain all things, he was made in the all-containing form of a sphere, round as from a lathe, and every way equidistant from the center. This is an old translation again, one that's easily available online by Jowett. So there are also many connections you can make with the Sefer Yetzirah, the piercing light of first creation, rushing down and creating the tree. And while there are many representations of the tree, the one D is using is the one that will later be called the Kircher tree, and it's the one commonly used by many Hermetic organizations, and it's very common in Christian Kabbalah. So there's a notion of a sphere there too, of time as a sphere. Remember we talked about cutting up hours? Well, that meshes with this perfect. And there is a notion in Hermetic Kabbalah, and people argue about whether this is true or not. I'll leave that to theologians, that of a Sephirah as a sphere. The actual word does not mean that. The Sephiroth are the 10 emanations of the powers of God. But if you have the idea that the light is emitted each place in a central point, then you have a sphere. All right, let's go on to the second theorem. It's coming here with an illustration. That's a pretty simple illustration, right? If you have your compass and straight edge, you could draw that. This is a line segment. That line segment is being used to make the circle. And so we have D tell us neither the circle without the line nor the line without the point can be skillfully produced. There's a pun here with skillful that it exists in Latin and not English, that it is an art, that an artisan can produce this, and thus there's an allusion built into the wise craftsman of the Timaeus. Therefore, pierced by way of the monad. Remember that long talk we had about what is Mercury and stillbone and the piercing stillbone and all these sharp pointy things that were going to appear, that pierce creation and then light rushes in. That's what you have going on here again. Therefore, pierced by way of the monad, things are first begun. And that which is related to the periphery can in no way be employed without it. So light has pierced creation and things are first begun. Something else here, the word that D uses for line here is just lineum. In that Latin of the first theorem that I read on the earlier slide, remember it was lineum rectum. He says lineum rectum first. That's the precise term for a straight line. But after that, he's going to and I'm sorry, I said lineum, I meant to say rectum. Here he is calling it a recta. That can mean straight, a straight line, a straight edge, or perpendicular. It also means moral rectitude, someone who is striving up towards the good or the bonitatis. Recta will also be used as a right angle, like the ones you got here. Remember, a 90-degree angle. So you get 4 of those right angles. You get a square. You flip it into a cube. Now, if you understood what I just said, you are going to coast through and understand the monad, which people have said is an indecipherable text, and it is not. However, if you require D to stop and explain the associations he expects you to make, you won't get through it. So D, for example, in a later theorem, when we're taking apart the cross of the elements, we'll never say the cross of the elements have 4 right angles, and if you flip them, you will get a square, and if you flip that again, you will get a cube, and that cube is a platonic solid, and you can associate it with earth, and you can put all of these things in another diagram and look at Aristotelian qualities like heat or moisture or dryness or and blah blah blah. No, he's going to assume that you make those associations yourself. He will talk about it displacing this point and pulling it up and making another shape. But he's not going to tell you, oh, which Greek philosopher to look at, what part of the Bible. Well, he sometimes will give you a reference to what verse in the Bible. But so you need to know what the reference is. But hey, that's why I'm making these videos. I'm here to help. You actually don't need to know, because I'm going to tell you over quite a few more videos going through each of these theorems. So let's continue on. Something else you ought to know about the second one. It's also an echo of Euclid. And you see, he didn't say, as Euclid says in book 1, postulates 1 and 3, but he echoes that as if he is talking to someone who knows Euclid very well. That part of Euclid concerns the necessity of having a point if you're constructing a line, and a line for the construction of a circle. Up here also notice he says monad, not point. Down here he will say point. Point is punctum. Monad is our English word for monas, which is the same in ancient Greek and Latin, different alphabets, same word. It is a one that contains all things. Usually, when we run into monas in Euclid's geometry, for example, it's translated in as unit. But our English word unit doesn't have all of the all-encompassing connotations of monad. So when it has all the philosophical ramification of everything going back into this one, then we in English tend to say monad. Okay, let's go on to the third theorem. Therefore, the remarkable central point of the hieroglyphic monad right there refers to the earth, around which the sun, moon, and remaining planets complete their own courses. Okay, pause for Terry to go on a digression here. This is the line that many well-meaning scholars, but very literal history of science scholars who are not used to transformational symbols at all, have used as evidence that Dee had a geocentric view of the earth. That is, that he believed the sun went around the earth rather than the earth going around the sun. First of all, in some cases, like here in Theorem 3, Dee is geocentric. Later on, he will be heliocentric. Why don't those scholars pick up the later heliocentric reference? Because in Dee's time, it would be blasphemy. Think of what happened to Galileo. So it depends on your frame of reference. And you have to, when Dee goes heliocentric, look at it by his symbols. And we'll do that in a later theorem. I do want to point out, though, that if you are looking at this Kabbalistically, which we'll do in the next video, your Malkuth, where you're standing, is on earth. If you are drawing up an astrology chart for someone, which Dee notably did for many people, among them Elizabeth I of England, you look at where the person is that you are drawing the chart up for. You're looking at the powers that work on a person where they are. So unless somebody's living on the sun, you don't draw up a heliocentric astrology chart. J.L. Heilbron, one of the big names in the history of science, in an introduction to Shoemaker's translation of the Propoitomata Aphoristica, points out that you could look at all of the Propoitomata Aphoristica as applied astronomy, that is, astrology. That today it's sort of the first applied science. And in many ways it is in the Renaissance, the first applied science. We just don't consider it a science anymore. Or I do, but some people don't. Okay, so when I draw up an astrology chart, what is it, geocentric? Yes. Did I learn in school that the earth goes around the sun? Yes. Okay, end of my point. Thank you for listening. So let's go back here. I'll talk in a minute about what happens if that center shifts, but I want to say some more things about this. The remarkable central point around which the sun goes. All right, this is the symbol for the sun, right? A dot and a circle. I talked about that in the context. It also is an early Pythagorean symbol for a monad, just by the way. It can symbolize other things like gold in alchemy, Tiferet in the Kabbalah. So the remarkable central point of the hieroglyphic monad refers to the earth around which the sun, moon, and remaining planets complete their own courses. And in this duty, because the sun itself assumes the highest dignity, we designate it because of its excellence by a complete circle with a visible center, as you see there. Now, what if this center shifts? I've talked about the center as a point of reference for us on Earth. What if it shifts? Well, there is a saying that you hear many great thinkers have variations on. God, or the good, or the divine, is a circle whose center is everywhere and its circumference nowhere. Is that Christian theologian Nicholas of Cusa, who lives a few hundred years before D? Why, yes, it is. Is it the ancient Greek philosopher Empedocles? Yes, it is. Is it the 20th century magician Aleister Crowley? Why, yes, it is. Is it Voltaire? Yes, and so on. Many people have said this. So a circle whose center is everywhere and its circumference nowhere. That's going to get important later when we start taking this apart and putting it together and try to figure out how exactly is it that John Dee thinks he has squared the circle, because he does think that he has. Okay, you get iterations of this also where the circle is a sphere. God is an intelligible sphere whose center is everywhere and circumference nowhere. Okay. So if you're with me so far, that's it for the first three theorems. What you need to do is go through them on your own and see if you understand them. Since you have early translations of the translation of that Dr. Turner and I did online, I'm going to drop a link for that below. You're welcome to look at it. And by the way, this is a great time to thank our sponsors, Geometric Models. They have all kinds of educational tools available that help you visualize geometric objects. Eventually, we're going to have, they have this whole thing on a torus. And yes, we're going to be talking about a torus, because by the end of this, John Dee will have a torus, even though it's not something very common in Renaissance mathematics. All right, folks, thanks for listening. I'll see you in the next video. Bye-bye.